Okay, so this is the GitHub repo of VisUI. So, contrary of mine, of the launch HMI, you have the README that is complete. You need to download the processing, which is an ED for JavaScript, Java or JavaScript. I think it's just for Java. And when you install it, you need to open and choose VisUI.pde to launch it. Then you execute, yes, execute, and you have your VisUI that is launched. So you can take the test one unit to see what you can do. I have a small problem because this screen is the smallest one. So when I have the when I start it, I cannot. Man, it's my computer fault. Like if you have a ground station that has 4K screen, it's a problem. You don't need 4K in the field. So here you have the testing file. What I will do is starting by showing you the global options. So you have the free bar here. You can choose a communication port. So I will choose mine because my system is powered now, and you will see some data flowing in. But for having a better visualization, because I did not tweak everything, you can also, for testing purposes, use the test data, and so your data is replaced by by random noise, and so you can visualize it. It's simpler to visualize it. You can also have the save data. So this is when you have the real data. You will save what is sent into the serial port in a text file. And contrary to the launch HMI, here it's already integrated that you can use the file afterwards. Like if it's saved and you need to replay it in VisUI, you can. So this is a great feature that you already have that I need to do on mine. But we will see what all of this is about. So you have VisUI, so this is just for normal use. Here you can load any configuration you want, and I will load my previous one. It should be easier, yes. So here you can load your configuration. Here you can add something, and what you can add the graph. You can add some sort of bar. You can have a gauge. You can have 2D graphs with 2 coordinates. Like if you want to have like a map of the field, not map of the field, but the trace on the ground of your rocket you can have. You can also have the 3D model and load a 3D model if you want. So this is something that is working, but you cannot like have 2 models or do an animation, but you can set up the positioning of the model, the positioning of some graphical interface, and like everything you have in the scene, but you cannot have 2 models or do like a 3D animation. You don't have that. We will add another one. You can have a video feed, like an IP video or a webcam or something. You can have a state. A state is meant to know the state of your rocket. Like we prefer to use an integer, so it's just something that tells us in what state is the rocket. Like, is it waiting for launch? Is it does it think it has launched? So it's something that we really want to have, because when you have a problem, you can start the launch phase early when you're still on the ground, and this is easy to see when you have a state that change in the HMI. What can I do? Yes, I can do this. So the state current is the one that is highlighted, and the other one has not the current state, so you know when it's switching. You can have a text area. Still, this is also very important, and something I asked for is to have a text that can basically display the raw data. Why do you need the raw data and not the graphs and everything? It's to know when you don't have any more data coming back, because when you have the text, you can see the raw value, and when the value freezes, you know you don't have any new value coming in. So this is the part when you can have this kind of information. You have also the compass. The compass is meant to know the direction. If you have a good gyroscope, because it will move a bit during the launch phase, you can use it. You can also use it if you have a magnetometer to know where is the North Pole and know the orientation of the rocket or something. Very neat thing. What I would have liked to do more is to have like you can replace it by a PNG of the rocket moving or something if you want to have the roll rate. But one thing I didn't mention is when you add something and you have the value, you can. It's not just the value you can have. You can do math. You can have an expression, you can calibrate the raw data and what you need. It's something, for me, I think maybe more acquainted if you know the Python, because if you know the Python, you can basically do anything, or have everything set up in the config file and download every time. But this is something very useful. Like if you have what we do with pressure, for example, when we have a pressure sensor, we basically remove the 1 bar atmospheric pressure. So we just have a number that is very, very small because the pressure is not moving that much. And this is easier to transmit the data by the telemetry because you can have a smaller, you can have more precision and send a smaller size of number of bytes. Like you can use an integer not signed and 1 or 2 bytes and it will be fine. You will have plenty of precision using it. But when you have your, when you use this, you can basically have the expression of pressure and do the calculation to have the height of the rocket. And my light just died. Okay, my lights are good now. So I would say that you can have your calculation of your height and altitude if you want, just here when you want to do calculation, and it will be fine. I mean, this is a pretty powerful tool. Also, it's in JavaScript. What is good with JavaScript is that it's pretty good at displaying things. Mine in Python works fine because it doesn't need to display anything. And when you want to display something like in 3D, it just crashed. But it's working because its only job is to take data and send it into InfluxDB. So it will be fine because it's the Grafana part that is doing the display part, and it's pretty good at that. Here, it's doing the calculation and the display in JavaScript, and it works very, very well. Like we used for other things, MATLAB or Python, and it's slowing. You also accumulate like a delay because when you're not computing fast enough the display, you start drifting, and when you have a drifting of 10 seconds, when you're not sure the rocket, you may have a lot of problem and data that will not be recovered in case of a failure. So this design, the Python one and the VisUI one, are great. But if you want to have something that works easier, that is easier to use, go with VisUI. Like you don't need to know how to code to use it. And if you want to tweak a bit and do some calculation or do your own HMI, you can use the repository of both Launch HMI and VisUI to modify it and do things and everything. Also, the guy who is doing VisUI is still working on it. So if you want to give him feedback or anything, he will gladly appreciate. So I think that's all for today. Have a great day.